I'm Simon Pearson. I'm Professor of Agri-Food Technology at Lincoln and founding director of Lincoln Institute of Agri-Food Technology. What I thought I'd try and do is just sort of talk about some of the new technologies and the opportunity innovation in this space. And I think a lot of us in this space, we've been in this space for a long, long time and probably thinking a lot of stuff has been done. And what I really wanted to do today is really show that we're actually at the start of the journey in terms of innovation for agriculture, certainly not at the end of it. So I think there's a long, long way to go. And we're getting some new technologies coming in, particularly around robotics and AI. I started this journey, as Sir Peter said. I did it. It was a Food Sector Council, wasn't it? Peter got me to do a task and finish group on agri-robotics, and there was one particular well-known person on that, Ali Kappa, who's a force of nature, I think it's fair to say. And she got me to say, how long is it going to take to get robots into farming to pick fruit? And so this was about 2017. I said, about 5 years. I thought, well, I'll be gone in 5 years. And nobody will come back and get me. Anyway, I was still around after 5 years. And I think a day after we published the report, Ali was on the phone, where's my robots? So I think we got there in about 7 or 8 years, but that's part of the journey. So robotics has been key, and then talk a little bit about the robotics stuff we've done at Lincoln. AI is now really there, and well, it's not really there. It's just starting actually, and we're just accelerating on AI. And then there's lots of other areas, and some of which will be specifically interested here. Now, what do we do at Lincoln? And we do very different things. We have a very different approach to innovation to pretty much anywhere, any other research groups, I think in the UK, probably globally. And what we specialise in is interdisciplinary research. And when we founded it in 2016. My background is son of a Lincolnshire farmer. And I had 7 years in Marks and Spencer in the supply chain, which was sort of buying stuff. And then I thought, well, this buying stuff, that's not too bad. I'll tell you what, I'll go and grow stuff. And then I ran a farming company selling to Tesco, Sainsbury and Waitrose. We employed we grew flowers, 900 seasonal migrant workers. If there's a choice in life between selling and buying, I recommend going on the buying side. It's a lot easier than actually growing the stuff and doing the farming. Believe you me. But I learned from that experience that agriculture is a truly interdisciplinary domain. And if you're a farmer, you spend your life thinking about a massive diversity of things. So you think about pests and diseases. You think about biology. You think about precision breeding. You also think about engineering. You think about the environment. You think about business. You think about everything. And that is the exciting thing to me about agriculture, and it pulls everything in. It's truly interdisciplinary. Now, the way that we've traditionally sort of looked at research really since the end of the AFRC, which I remember when I was at university, we became a little bit bioscience-y focused in the UK ecosystem, when actually agricultural innovation needs a massive diversity of skills, knowledge and disciplines coming at it. And I knew that from my agricultural background. So when we set up LIAT, I wanted to do something very, very different and really do an interdisciplinary play. I was given a blank sheet of paper by the VC at that time, and she said, just do something you want to do, agri-tech starting, show us how it's done. So I thought, right, okay, we'll do it different. And so how do you do interdisciplinary in agri? Well, what you do, you've got to have fantastic networks. And so the first thing we did was went out, we had fantastic networks. And those networks are science and industry networks, and also policy networks, but primarily science and industry networks. And we started off initially sort of building relationships around science partners, and that's colleagues who might be engineers, computer science, business, chemists, life sciences, the whole lot, you name it. And just to give you a span of what we do now, I'll come on to what we do with our CERES program at University of Cambridge, but we've now got projects with 50 different science disciplines engaged in them, 50, ranging from nuclear physics to engineering to genetic engineering, the whole lot. So we're crowding in this skill base, but crowding in skill base is all well and good, but you've got to start with industry-focused problems. You've got to actually identify what those problems are. So you've got to have a network that is deeply embedded in industry, and we started that network through the Great Lincolnshire LEP, Civic Society, a chap called Martin Collison, who Sir Peter knows very well, who gave us many of our connections into industry, but those are local farmers, particularly Dyson Group, and national farmers, now international farmers. So you've got to know what the problems are. And then you crowd in other universities. So we now work with 24 different universities in different projects across the UK, because the skills that you need to solve these problems are not necessarily in-house. You just need to know where to find these people and entice them in. We work very closely with DEFRA. I wrote the automation review in horticulture with George Eustace when he was Secretary of State. We've done quite a lot of stuff on the industrial strategy. You've got to work with the agri industry, you've got to work with supply chain, and we work with the food industry and particularly the digital industry. So interdisciplinarity is about these massive networks of people. And then through those networks, what we've been able to do, just to show you, I am a bit of a collector, and I've been collecting UKRI cards for the last 7 or 8 years, and we've got funding from all those research councils, Science, STFC, EPSLC, Innovate, NERC, Research England, BBSLC and ESRC. The only one I haven't got is AHRC, which is Art and Humanities. So if anybody's got any ideas, I'll give it, oh, okay, Paul and I are gonna have a chat at the end. I'll give it a go. But that proves the point, and it proves the point that of the interdisciplinarity of agriculture. So there is funding for agriculture that we've achieved through all of those research councils because it's an interdisciplinary play. So we work closely with BBSLC. Actually, our smallest fund is probably BBSLC. Our largest is probably Research England, followed by Innovate UK and EPSLC. So I think that just shows why it's interdisciplinarity. And one of my journeys, one of the reasons I'm here is to try and sort of engage with people, say, if we rethink about this, we can actually expand and we can crowd in much more research and innovation into agriculture, and it can give us a fresh look. And I hope that that's what we can, that's what we're trying to do at LIAT anyway. So research funding from all those, we now organise 2 CDTs, which is 110 PhDs. Those are with Cambridge UEA, which is robotics. We have the AI for Agriculture CDT, which is Queen's, Aberdeen, Strathclyde, and Lincoln. So 110 PhDs, which we are looking after. We've done around £150 million of Innovate UK interventions, and we've had £17 million of funding for research translation, which is my favourite bit. And we don't just do the conventional research bit where you do a project, you move to your next project. We do some of that, but our core mission is to translate our technologies. And what we want to do is commercialise technologies. And as an academic, there's a cultural thing in academia. Lots of people like to publish open stuff to get impact. We do some of that. We are passionate, locked on to the case that we believe, and I'm not, people look at this very differently, can have different opinions, which is fair enough. We believe the best way to secure impact is to commercialise something, and that's commercialise it, get it into industry, it's self-sustaining, commercialise it, and on it goes. And so impact delivery to us is important. We do it through commercialisation. And that means translation, creating spin-out companies and licensing, and that's what we've done through our CERES program with Cambridge. So that's our philosophy, which is our guiding star. So we're laser focused on interdisciplinarity, commercialisation, and networking. So what are the new technologies that we're excited about? Well, we're still really excited about robotics, and we're still particularly excited by AI. And I thought what I'd do is do a bit of work on ChatGPT and just show you how good AI is at the moment. And I thought for you guys, and I knew Ben was here, I designed for Ben with my AI thing a new strawberry harvesting robot on the left. You've not got that one in your greenhouse yet, and that one's a sheep harvesting robot. So where are we going with this space? These things are mad. AI is brilliant, and it's way off. But I think on all these technologies, we are genuinely making fantastic progress. And Dyson Farming is an exemplar on strawberry harvesting robots. I think you're there, and I think it's pretty well known that you're robotising from 2026, which is one hell of a step forward. Yeah, 7 years, Peter, I think, since a review when we said 5, but we're about 7. I think that's fantastic, and that's with dogtooth technologies. But it's beyond that. There isn't now. I don't think there's a single vegetable farmer in the United Kingdom who hasn't looked at robot weeding, and that will be from eco robotics or carbon robotics or whatnot. And that has all emerged in the last 3 or 4 years. But I don't think, and that's because of herbicide pressure, losing of active materials. I don't think there's a veg farmer in the United Kingdom who's not looking at or got a robot, which I think is a breakthrough moment. On strawberry harvesting, we think Dogtooth will have sold about 100 of these things next year, which is a breakthrough moment. And Saga Robotics, who span out of some of the work we did at Lincoln, with a 40 million investment, they're now treating, I think, 40% of all UK strawberry crops with a UV robot against powdery mildew. And that's been rolled out now in California. They've spun out, they've now got a Californian company, but still a lot of their development stuff is at Lincoln. Then we have our own AI company, which is FruitCast. We have an AI company which does crop forecasting on strawberries. We've now got 15% penetration across the whole UK market. So these things are now really, really developing. And I just wish in that report it's 7 years, not 5, and I think I'd have been all right. And then there are other opportunities. There's a sheep shearing robot there. If anyone's, I think the sheep's not particularly interested in that one. So why are we developing these systems? Well, we know why. So the world's changing. We've got to deal with these problems. I think the political state is really deeply troubling at the moment, and it's, in my own view, it looks, it feels as if farming, you're going to be a bit on your own, and so that absolutely, in my opinion, means productivity gains. And the question is, where are those gains going to come from? And they're going to come from the innovations. Ben's described some, Tom's described some. And we think robotics and AI is going to be key. And it's about getting as much productivity out of every square metre as you possibly can. For horticulture particularly, robotics is going to be absolutely key. And for an agriculture, I think AI will be key. And it's that data piece, again, which Ben absolutely mentioned. And we're just at the start of the AI revolution of farming. So this is some of the stuff we do at Lincoln. If you've not been there, we're at Rhizome. It's fantastic. It's a 400-acre farm, right in Lincolnshire, heart of UK farming, in my opinion. Ben will agree with me. Maybe not all the rest of you will. But we really look. So we've got all sorts of things. We've done lots of robotics in agriculture. That was a wheat phenotyping robotics. We've done lots on mobile platforms. This is the Saga UV story. We just demonstrate that in a little fruit farm, and it worked brilliantly, and they made a massive business out of it. And that's the innovation there is the robot. It's the autonomy stack. There is no GPS inside a tunnel, so you've got to have a robot stack that works without GPS, and that's been done. We're doing lots of harvest assist. This is an image of Jabas, our latest startup, and it's a fruit logistics support company. Provides an autonomy stack. So pickers call a robot. About 20% of the picker's time is walking. Pickers call a robot. Robot goes to the picker, takes the trays away, and keeps them going. And it does it safely. The left shows the robot world, what it's seeing. The right just shows how it interacts with people. Pickers are scarce. The government is reducing the number. We don't want to run anyone over, and that just shows how it's interacting with those people. And it's a genuinely clever piece of innovation. Here it goes in a row, and it's trying to navigate into the row, and it's got to interact ultimately with people. So you see the robot world on the right-hand side there. This is FruitCast AI. This is one of the AI opportunities. We're doing this in all sorts of crops, from wheat to tomatoes to strawberries. The AI is detecting each individual fruit. It's massively scalable. We can measure 3.5 million fruit a day, and then we can do an individual forecast for every fruit. Every single fruit, we will do a forecast. So farmer then gets the yield. You can then set the price, and you can set your sales profiling. And then the reason I was late today, I was at G's with agaricus mushrooms, just looking at our latest install, which is really exciting. And 3,500 mushroom pickers in the UK, 94 pence per kilo to pick labour, to pick mushrooms, and we have a robot to solve it. And we're very, very, very close now to a breakout. Dog2 think they've got the first scalable robotic solution. I reckon I have. So it's a race on. So, so we are genuinely very close. And we're working on other crops, working on mushrooms, we're working on lettuce, we're working on broccoli, we're working on blueberries, we're working on all sorts of stuff that's going on. And then I think, well, what is the future of farming? Is it this? And this is just a video some of our PhD students did last year. This is sheep farming. Nothing to do with crops, but I'll just show you, is this the future of farming? Sheepdog's quite happy there. So we thought we'd give this a go. And we've got this lovely little robot dog. It's Boston Dynamics thing called Spot. It's got a name. And we thought we would herd sheep with it. And you see the sheep reacting to it. They love it, don't they? And they think, what is that thing? Sort of sheep sort of looking at the Terminator movie for real, isn't it? And they're absolutely adoring it, aren't they? So the sheep's sort of moving around, and you see the dog. If you've got a sheepdog, though, you've got a major USP, because the battery life of that robot is 40 minutes, and I think the battery life of a sheepdog is much longer. And then we did some sort of some herding behaviour stuff, where we used AI to track sheep and looked at how they responded to the robot, exactly the same way as they respond to a dog. So there's lots of opportunities for space. And then finally, just moving on, the last thing we do, I think it's the most important thing, and we have money, academics, we have money, so we can award money. So speak to me at the end of it if you have an idea. We do an awful lot of research translation. If you read Sir Ian Chapman's speech from UKRI, which he did on Monday, where he set out his vision for UKRI, you will see a very large focus on commercialisation. So you'll see a focus on 40% of UKRI funding to go to curiosity-driven research, great. But you will see a new focus on research translation. And that is absolutely, that message is coming down from the Treasury into DCIT, into UKRI, and the Treasury is saying, I'm investing £9 billion a year in British science, I need a return. And in Chapman, what he's looking for, his measure of success at the end of his term, is to get the first $1 trillion UK startup company, which God knows what that's going to be. It's got to be quantum or something like that. But within that, there is a laser focus on commercialisation and translation. And I would say one of the biggest problems in British science is a translation failure. Sorry, I've been really clear. So how do we do it? This is one of the ones that we do. So we have a program called Ceres, which is where University of Cambridge is spun out of Cambridge Enterprise. Cambridge Enterprise, there aren't many big universities in the UK who know how to do translation. You'd probably argue it's UCL, Imperial, maybe a bit of Aberdeen, Cambridge and Oxford, 5 or 6 who do it really well. So we work with Cambridge, the team that put together Ceres, the same team that did Apollo Therapeutics. They developed a process where you find need. So you speak to industry. Apollo, they spoke to GSK, AstraZeneca, Johnson & Johnson. Tell me what the need is. They then found the academics and mapped them up to need. Train the academics in commercialisation, and that means not writing a grant, but writing a business plan, which is then pitched to an investment committee who are non-academics. So Haldane principles completely out the door. It's money given by business investors to academics. It's very different. And so the pitch goes through. If you win, if you're successful in the pitch, you get the money that night, but the grant is milestoned. So if you miss a milestone, it's done. You're over, and the money's then recycled. And academics don't really like that, and that is one of that is one of the things we try and manage. Especially, rarely things fail. We don't invest in things on the view that things are going to fail. The failure reasons are usually 2 things: hypothesis not proven, or it's team, and if the team don't deliver, and which is interesting as well. And so we get into the really into the granular detail of how you take these things forward. So Cambridge developed that process with Apollo. They then spun that out into their own company, and that company's now raised $500 million of Boston East Coast venture funding. Very, very successful indeed. And so we're trying to use the same model here, and with the same model absolutely works. We do it for agriculture, and again we are challenge led. We find problems. Sometimes you get academics who might push stuff to us. I've got this brainy idea. That's great. We'll push it along. Other times we'll actually look at the idea and go, okay, we'll found a project. So we'll speak to them, and them, put them together, create a team to solve it. And that's a very, very successful way. And that drives genuine transformational innovation. So that's how Ceres works. So we have money. If anybody's interested, speak to me. And just to give you an idea of the, I'll close out soon, Peter. Just to give you some of the ideas. So we've got a strand on reducing environmental impact. These are some of the we funded 50 projects so far. We created 4 spin-outs. We've got 9 in track. So that's 13 likely spin-outs out of 50 projects, which is a very high conversion rate. So we've got stuff on nitrate runoff, direct air capture, variable rate fertilizers, novel pesticide removals. We've got seaweed stuff, composites. That's a spin out. That's UEA. They turn flax into car body panels. Biocomposites, batteries, biopackaging. We've got a thing, crop loss and waste, a lot of disease stuff in here. We've got lettuce harvesting, that's a project with California. Pathogen detection, that's AI. Blackgrass detection, that's AI. That's a cool project. We've got a computer scientist from Disney came in and did some amazing stuff with blackgrass recognition. Strawberry decision support, robotics, novel pests and diseases, control, etc. So the point of this, I want to show the diversity of what's going on. You know, there's a massive diversity, and from that funding opportunity, as long as you're challenge led and you identify those problems really clearly, you can get onto a whole range of really interesting projects. And some of these are going to spin out. Some of them are not, because the projects, sometimes the business model's just not there, and so you have to stop. And then we do things with next gen. So we've done disease resistant bananas with Cambridge Plant Sciences, fungal bioinoculants, etc., etc., etc. So that's what we do. I want to close it there. I can see Peter's getting fidgety, so I'm going to close it there. But I just wanted to say there is a different way of doing innovation in agriculture, and there is massive opportunity in this space. That's it.
So really interesting stuff going on there, Simon. Do you want to just Any questions before we go to a panel session? Yes, sure. Mentioned this fantastic opportunity for innovation. Do you think there'll be a translation from some of the things developed for the high value horticulture crops into the broadacre wheat and oilseed rape type crops? Or do you think the price point will mean you will always have to do a different kind of way of doing it?
Particularly things around sensors, hyperspectral imaging, all that sort of stuff, nitrogen application stuff, green fertilizers. I think there's massive opportunity in that space. I mean, it's fair to say we have a fresh produce bias. Lincolnshire's got 60%. I don't know, it's Lincolnshire, Cambridgeshire, 60% UK veg. We've got a lot of fruit in our area, so we do have a bit of a local bias. But there's a massive opportunities for crop-based systems that, we work very closely with Dyson on many of those applications.
And look, I was there on Monday. I heard Ian Chapman saying about the translation, commercialisation, absolutely critical question. So that would take that one first.
With the AI use, sorry, Savannah Van Mesdag, with the AI use, do you have a calculation system for working out how much energy is used and how much water is used with the AI use? And do you have ways to mitigate that energy use as part of this whole project?
Sustainable AI. It is a major issue. It's an emergent issue. We've helped the Royal Academy of Engineering, done a major piece on sustainable AI. I refer you straight to that. It's really important and we can't forget it. So
yeah.
Question here, sorry. Then I'll get the panel up and get ready, please, to come and sit on the panel.
I just wanted to ask, obviously with a lot of academics, there's good ideas that come into play that go through the sort of process of being able to invent this sort of machinery. But then when it actually comes to being on farm practically, sort of some issues start to arise. Is there been efforts from the sort of projects here to try and like contact people on farm, asking them their opinions and highlighting possible issues that might come up?
Every single project goes through a robust investment committee, and we've got people like Richard Williamson, who was the CEO of Dyson Farming, on it. Mark Southern, we've got people from Sainsbury, we've got people from Syngenta. So we've got a very diverse mix on there. So everything is challenged from the farmer's perspective and the industry perspective. And then all of our projects, we expect work on farm because it's the acid test. What tends to happen is you get a lot of low TRL stuff going on, and this is a translational failure. A lot of low TRL stuff looks exciting in a controlled environment. Then it hits the massive complexity of farming and it unravels. So if you want to translate, you've got to get on a farm and you've got to prove that technology works in the complex environment we've got.